So, were you successful? Let's do the same for the password. Of course, it should be fairly trivial. We create our password reducer, which is an anonymous function that gets the last state and the action. And yeah, well, we can't just copy this, can we? We can copy this in here. The validation code needs to change because for the password, I'm checking the length. So I want to copy this code down there and use this here and here. The action names can be the same. But now, of course, we also need to call useReducer again here. Now for the password reducer. And what we get back, therefore, is the password state and the dispatch password function. We also want to set an initial state, which can be the same one as here for the email, of course. Just this object with no value and a null is valid state. And now we simply have to update the code accordingly. Set form is valid. Here I'm not interested in the entered password, but instead, now that we do validation in here, I only want to access my password state, and there the isValid prop. And when the password changes, I want to call dispatch password, pass an object where I have the user input type and the val field, which is the event target value. And here, when the password field blurs, I also have dispatch password, and the type is just input blur. And here I'm not caring about the entered password, but the password state and there the value entered by the user. And then we can go down. And for the password field here, we have password state is valid in our check. And we feed back the password state value into the input field. And if I go up, we see we use nothing here, so we can comment out these two use state calls. And with that, again, if we give this a try, this all should work just fine, and it does. Now that wasn't too difficult, hopefully. It's again the same what we did for email reducer. And of course, you might see potential here for using just one reducer function instead of two, because it's almost the same. The validation logic is different though, so that's definitely refactorable, but takes a little bit more work, which is why I'm not going to do it here. But generally, it's not too far off. And in addition, and that's the thing that matters more to me here, the form validity, of course, also is a bit related to the input validity, because the inputs are part of the overall form. So the code we have here is still not optimal, because we still derive the form validity off of our state, which is still not what we want, due to the reasons I explained earlier with React scheduling the state updates. So we might still refer to an old state here that does not change just because the state is coming from useReducer. Set form is valid, like this still is not optimal. And in addition, having our state that is split like this, even though it technically belongs together, is also not something you might want. Now, whether you want this or not is up to you, but the fact that this is not optimal is a fact. So for this, let's comment this out again, and let's go back to the useEffect solution, which actually is a nice solution. So we can go back to this and just update it accordingly. Here we have the email state, and there simply is valid instead of doing validation here. And the same for the password. We have the password state is valid, just like this. And hence here we care about the email state and the password state. And this would now be a fine way of calling setForm is valid, because since it's now inside of an effect, we still refer to our state snapshots, but this effect is guaranteed to rerun whenever these states change, and therefore ultimately it will run with the latest state values. So this actually is now an okay way of updating a state based on other state. Because with useEffect, we're guaranteed that this will run for every state update React performs, which was not the case before, where maybe the code ran too early. useEffect only runs after state updates, so here this is okay. Now still here we have a problem though, which is why I'm showing this to you. This now will run accordingly and correctly, and hence here, indeed, if I enter something here, eventually this unlocks and works. But the problem we'll have here is that this effect runs too often. This will run whenever the email or the password state changed. Now that includes cases where maybe just the value changed, which might not be what we want. We actually only care about the validity here. Now it turns out that we update the validity now whenever the value changes as well. But of course, if, for example, the input was valid already and we then add an extra character to the password, it doesn't really change. It was valid before. With the extra character, it's still valid. So here, for example, if I have a password that is valid, if I add one more character, it's still valid. Nonetheless, our effect re-executed here. Now that's something we might want to avoid, and it re-executes at the moment because our dependency is the entire email and password state, not just the validity part of it, which is actually the part we're interested in. Here we can use a technique which you need to know, which is why I'm showing it to you. We can use object destructuring, so the same as array destructuring, just with objects, to pull out certain properties of objects. For example, from email state, we can extract isValid and store it in a new constant of the same name. And we can do the same for the password state, but since I'm already using isValid in this constant now, we can use a variation of the object destructuring syntax. We can add a colon here, which now won't assign a value because we're not creating an object here. We're using it on the left side of the equal sign. This is simply the syntax for object destructuring. And with the object, we now assign an alias to the extracted value, to the extracted property. So we're pulling out the isValid property, but we're storing it in a constant which actually could be named email isValid. And the same here for the password. We're pulling out the isValid property, but we can store it in, let's say, a password isValid constant. So this is an alias assignment. This is not a value assignment. It's an alias assignment because it's part of this object destructuring syntax, which is the syntax you're automatically using if you're using those curly braces on the left side of the equal sign. And now we have the email and password isValid constants, which we can use here as our dependencies and as our values. Your dependencies should be matched by your values and the other way around. So email isValid and password isValid. Now the advantage is that since now I'm pulling out the isValid state here, whenever just the value changes and the validity did not change, this effect will not rerun. And you can see this. If I enter something here, of course, in the beginning, it will run. But once the password is valid, if I type one extra character, you don't see an additional checking for invalidity output. This is especially clear if I clean this. You see, I can type a lot of characters. This never checks again because the validity did not change. Of course, that's not the case if I make it too short. So I wanted to show this because this is an important concept to further optimize useEffect and to avoid unnecessary effect execution. Not just when using it with useReducer, but for example also when doing so. Another use case could be if you have props as a dependency for your effect. You don't want to rerun the effect whenever props change, you only want to do so when some props change, for example. With object destructuring, you can get there. So that's a little step back here to useEffect, but an important one. An equally important concept, of course, was useReducer though.